All right, so today we're talking about rates of change and motion in a line. You guys are going to be able to determine acceleration as well as velocity and how to model it as well. Okay, so let's just review real quick. The derivative basically tells us the It also gives us the rate of change of one variable with respect to another. Okay, it also gives us the rate of change of one variable with respect to another variable. So there's two different types of rates of change. You have average rate of change and you have instantaneous rate of change. Now, if you did pre-calculus prior to this class, then you guys would have already dealt with average rate of change. Average rate of change is how your y's change with respect to how your x's change. Okay? And you've done this before in Algebra 1, Algebra 2, Geometry. For those two pre-cal, you did it in pre-cal. This is called what? The change of your y's over the change of your x's. It's like, what kind of slope? Like, what kind of slope?
Like when you do y2 minus y1 over x2.
Yes, old school slope. y2 minus y1 over x2 minus x1. That is average rate of change, okay? How your y's change over, divided by how your x's change, okay? So, let's look at an example of average rate of change. A diver jumps from a platform at time t equals 0 seconds. The distance the diver is above the water at time t is given by that equation that you see there, where S is in meters, okay? So that equation represents how high you are above the water at a particular time. We want to find the average velocity of the diver over the given time intervals, okay? So what you're basically about to find is how quickly they are falling into this pool of water between 1 second and 2 seconds. These right here represents time 1, time 2. Okay, that's what these two numbers down here represent. Okay? So, how do you do that? Well, you pretty much need to figure out, okay, well, where am I at once? Where's the diver at 1 second? Where's the diver at 2 seconds? Based off of their height above the water level. So you have to find S of 1 or S of 2. It really doesn't matter as long as you stay consistent. How high they are at 2 seconds, subtract it from how high they are at 1 second, and then divide it by the actual time. Because in this case, t represents x. Is everybody following? Okay. Let's use your calculator for a few of these problems. So let's go ahead and figure out what is S of 2. That literally means we're going to plug 2 in for t into our equation. And then also we're going to plug in 1 into our equation as well. Okay? So let's figure that out. Let's figure this out. Okay, so for S of 2, we got what? 0.2. For S of 1, we got 10. So it's 0.2 minus 10 all over 2 minus 1. What's 0.2 minus 10?
9.8.
Negative 9.8 over 2 minus 1, which is 1. So that's going to be negative 9.8 meters per second.
So we have to have a unit in it as well.
Yes.
When you put it like that, that doesn't seem so bad.
Okay, so basically what that's saying in context of the question is that between 1 and 2 seconds, this diver is, the negative would be what?
In the water.
Like getting closer to
Falling,
the water.
decreasing at 9.8 meters per second. Okay?
Oh, so negative indicates that he's going down. Falling.
Yeah, something is either is going down, something's decreasing, his height is decreasing from how high it is above the water. Okay? I want you guys to do this for each of these different time intervals. And I know they're backwards. I don't know why they're backwards, but between 1 and 1.5 seconds, 1 and 1.1 second, and then 1 and 1.01 seconds. I want you guys to find the average velocity of this diver between each of these intervals. Everybody understand? And again, you can use your calculator. Okay, teachable moment, guys. Looking around, everyone's doing the same thing, which is okay. So that just means we'll correct it all at one time. As tempting as it may be to say that the first 15 days is from 1 to 15, you're thinking of it in the concepts of like a calendar. When you flip the calendar over, right, it starts on day 1. But this is a function to model this situation that represents the first 14 days. So if you were to graph this, where do you actually start? 0. So the first 15 days go from 0, your initial starting point of these first 15 days, all the way up to 15. So it shouldn't be 1 that you're using. It should be 0. So the first 15 days is from 0 to 15. Because again, 0, anytime you're thinking about time, years, seconds, the first of anything, you start with 0. Okay? So if you put a 1, change it to a 0, make the adjustment. All right, so now let's go ahead and let's figure this out. The average rate of change in the temperature over the first 15 days, that's going to be C of 15 minus C of 0. If you did 0 first, then 15, that's fine. Just make sure you stay consistent. What did you guys get? The answer. Negative 0.06. It is 0.6 because degrees Celsius per day, because 3 significant figures, you start with your first non-zero number, which is this. That's your first significant figure. Second, third, you always start with your first non-zero number. And I'm guessing the number after the 6, Travis, was a... It was a 4? Okay, something that didn't round it up. Now you have to find the rate of change in temperature on day 15, okay? So that means we have to do the what?
Derivative.
Have to do the derivative. And yes, this is going to involve product and chain, okay? The derivative of 20 is 0. That goes away. So now we apply product rule. Remember, product rule says the first times the derivative of the second plus second times the derivative of the first. So that becomes the first times the derivative of the second. Here's the second function. It is chain. So we have to find the derivative of it. What's that outside function? Inside? So what's the derivative of e to the x?
E to the x.
But I'm not going to put an x.
Negative t over 3.
Negative t over 3. Then I multiply it by the derivative of the inside. What's the derivative of negative t over 3?
Negative 1 over 3.
So my derivative is negative 1/3 e to the negative t over 3. So that's the first times the derivative of the second plus the second times the derivative of the first. What's the derivative of negative 9t? Negative 9. Now at this point, don't worry about simplifying, because what is it asking you to do?
Just find the thing.
Find the value at 15. So go ahead and plug 15 into this derivative. I mean, if you simplify, there's a possibility that you may simplify incorrectly, when really and truly all you just need is just to plug in the value of t. So we're plugging in the value of t, which is 15, into the derivative, which is what we got in the first line of green. And when you have an answer, Shout it out.
$4.49.
Double check that.
Okay.
Make sure if you have any error messages that you're using the negative, not the minus. Should be a decimal. 0.24. Should be a negative.
Negative 0.364.
No.
I got negative 1,003.
It's really big. So typing it in, then we have 0.24 what? 243. I know it's per day, but nothing. Questions on rates of change. Questions on rates of change. All right. Okay. So let's see how you guys did for part 2. Okay. And again, it doesn't matter whether you do 1.5 first or 1. Okay. But you basically are plugging in each of these into the function and subtracting them from each other and then dividing it by its placing. Just make sure that if you did a 1.5 first, then you did 1.5 on the bottom first and vice versa. Okay? What you guys get for your answer?
Negative 7.35 meters per second.
Negative 7.35 meters per second?
Yes.
Yes? Okay, good. It should definitely be negative. Again, it's representing over time what's happening to the diver. Okay? It's falling. Negative. Okay? 1.1 minus S of 1 over 1.1 minus 1. What you guys get for your answer?
Negative 5.39 meters.
Yeah.
39
Yeah.
5.39.
meters per second. Okay? And the last one? Realize that you did S of 1 already for
1.01.
the other ones.
1.01.
Oh, thank you.
Got negative 4.9.
9.
5.
So they did accuracy.
Yes?
I mean, I feel like that's the right answer. We just.
Okay. Just be careful of where you place your parentheses and things when you're plugging it into the formula. Okay? Because if anything, it's going to be this part right here, the S of the value. That's probably, if anything, the numbers start to differentiate.
But he's going that distance per second, like he's kind of fast for a human.
Okay? So basically, this represents, again, over time, this diver is jumping into the water, how much his height is changing. Okay? Over time. So, let's take it back. This original problem is a...
Average.
I'm talking about the equation. I'm sorry. S of t. What does that represent? What does it look like?
Quadratic.
It's a quadratic that opens
Downward.
downward. So basically, you have this quadratic. This diver is initially 10 feet above the air, and at some point in time, he's going to fall into the water because this right here represents the water. Okay? And so over time, between 1 second and 2 seconds, you guys are basically finding all of these different what? What? No, these aren't tangents. What are the lines that go through the circle or through the curve? They're called not all the way through.
Oh, all the way.
Wait, can you say that again?
All right, bringing it back. This right here is a tangent line, but this here is called a what?
Invasive line.
Say again.
Secant.
It's a secant. You're finding all of the slopes of these secant lines And they're getting smaller and smaller and smaller until eventually you get to what?
The tangent.
The tangent line, aka the derivative. That is called instantaneous rate of change. So that's the difference between average rate of change and instantaneous rate of change. Average rate of change is old school slope, okay? You're finding the slope of each of those chords over those time intervals. But instantaneous is asking at that very instant, at 1 second. Okay?
Because the other one's between two different.
Exactly. Oh, so so that is looking over time, but at one particular time,
Instantaneous
what is that?
velocity has to do with the derivative.
Mm-hmm.
Okay.
It's asking you what is
We got
that
there.
that rate of change, that instant rate of change. So all you have to do is the derivative. What's the derivative of the function?
It's 2 times 4.9, which would be negative 9.8.
Negative 9.8t,
Plus 4.9.
4.9. So to find the instantaneous velocity of the diver at 1 second, you take the derivative and then plug in 1. And then you'll find out exactly the rate at that particular time. And what is that?
Problem asks for instantaneous velocity. We just
Do the
find
derivative.
and
Plug in that value.
It's literally just
And if you look at your other answers between 1 and 2, between 1 and 1.5, between 1 and 1.1, between 1 and 1.01, the number was getting closer and closer and closer to
this.
negative 4.9. Okay? But that's the derivative. That's what we talked about when we first went through those burning sands, the formal definition and everything. Okay?
What happened? Is on our quiz, are we gonna do like no formal definition?
Yes.
So everything we've done so far.
Yes.
Wait, is that in the reference book?
Yes. Formal definition is in your reference book, along with all your rules and along with all your trig derivatives.
So we have the advantage.
So you do. Okay? Let's look at this one. I want you guys to do this one on your own. Okay? During 1 month, the temperature of the water in a pond is modeled by the function where T represents the number of days and C is measured in degrees Celsius. Find the average rate of change of the temperature in the first 15 days of the month, and then find the rate of change of the temperature on day 15. Average rate of change means
The slope.
which one? The secant line, so old school slope. But find the rate of change of the temperature on day 15. It's the derivative one. It's instantaneous, okay? So I want you guys to do A and B.